Okay, another great example here of the divisibility one. So pre-filled in the basics. Okay, once again, you need to make sure that you've made your PN statement. Okay, you proved that P1 is true. You've said that P1 is true. Then we're going to assume that PK is true. So we're saying because it's divisible by 3, we're saying show that it's equal to 3a. And again, you must state that a is a positive integer. And now we want to prove that pk plus 1 is true. So what we're going to try and do is mess around with this, make sure that we can sub in pk, all right, use pk, and we want to end up showing that this is 3 times some sort of integer. Okay, it might be 3a plus 1, 3a plus whatever. Okay, so here we go. We'll stick with the purple. Okay, now I have left a little bit of a gap underneath pk because I always like to rearrange it. All right, I like to see it there, not have it in my head so I don't have further opportunity to make a silly mistake. All right, so if we look at this, how can we substitute in this statement here? And that means we have to break up our k plus 1. We're using basic indice rules, right? 7 to the 1 times 7 to the k times by the same base, so we add the powers. And so we can definitely say that this line equals the next one. And now I can substitute in my 7 to the k to be 3a take 2. Okay, so we'll just show that this bit here, okay, we've replaced it. And we've got our plus 2. And the bit that I always forget, and I forgot that in the other video as well, right, using pk. Okay, and now we're just going to say that 7 times 3a, 7 times 2 is 14 plus 2. And we can see where this is going because we've got 7 times 3a minus 14 plus 2 is minus 12. And we can now pull out that common factor of 3. 7a, take 4. So therefore, pk plus 1 is true, aka it's divisible. So maybe we should put that back up there. When we say it's true, we're saying is divisible by 3. So we've got, therefore, pk plus is true since 7a take 4 is an integer, right? Because a was an integer and there, okay? So, huzzah! And don't forget then you would write your induction statement, which summarizes what you've basically been doing. So, since P1 is true and PK plus true, PK plus true is whenever PK plus 1 is true. Stuff that up. So P1 is true and PK plus 1 is true whenever PK is true, then Pn is true for all n greater than or equal to 0, greater than or equal to 1 by PMI. All right, let's get to the heart of this question, and that is the part B and part C. So hence, show that 7n take 1 is divisible by 3. All right, so we've got this hence bit. Okay, how are we meant to use this in order to prove this? So maybe you can't see it straight away, so what can you do to help yourself? Well, let's write it down. What did we actually prove? We proved that 7 to the n plus 2 was divisible by 3, so equals 3a, where a was an integer. And we're sort of thinking, well, what's going on here? How does this link with this? And you fiddle around and do some stuff, and we've got 7 to the 2. What if I took 3? Does that 2 take 3 equals minus 1? And what I do to one side, I'm going to do to the other. So we end up with 7 to the n take 1 is equal to 3a take 3, and we can see that that's got a common factor. And since a was an integer, we can say, well, therefore, 7 to the n take 1 is divisible by 3, right? Since a take 1, right? Because it's 3 times an integer. Because that is an integer. Okay? Okay, we're trying now to prove this is divisible by 9. Two things lead us into what we should be doing here. So the first bit is that it's asking us to use part A and part B. And personally, I'm looking at this 9 here. Okay, so if it's asking us to use part A and part B, let's have a look. What is part A saying? It's saying that 7 to the n plus 2 was divisible by 3. And then we proved that 7 to the n take 1 was also divisible by 3. So I'm going to call it 3b, right? A and B were integers. And we're looking, right? Can you actually see again? 3 times 3 gives you the 9. So I'm going to go, what happens if I now go 7 to the n plus 2 times 7 to the n take 1? Right, this equals 3a times 3b. What's 7n times 7n? That is 7 to the 2n. 7 to the n times minus 1 is minus 7 to the n. 2 times 7 to the n is 2 lots of 7 to the n. Take 2, this equals 9ab. And remember, a and b are both integers. So therefore, we've got 7 to the 2n plus 7 to the n take 2 equals 9ab. Right? Finish it off. Oops, sorry about that. Therefore, 7 to the 2n plus 7 to the n take 2 is divisible by 3. Why? Because a and b are both positive integers. Oops, not 3, 9. Sorry about that. There we go.